So we really love GitHub at Kubernetes. We use just about every feature and checkbox there is, and we tap into the extensive APIs they offer to do a whole bunch of different things. I want to start off with this because we are going to be talking about a lot today about bridging gaps in GitHub. When we have a project at the size and scale of Kubernetes, we've run into some unique challenges. But we wanted to start off by saying we really love GitHub. No matter how you slice it, Kubernetes is a huge open source project. So we have our 5 primary GitHub organizations, about 175 repos, a ton of teams, and about 1,000 unique members. Scaling the process to manage this many people has been a challenge in itself. In particular, before we started on any of this work, our new membership process was being handled by email and done manually with no visible audit trail. So I wanted to kind of give you a frame of like the problems that we were trying to tackle. I wanted to walk through one of those manual processes. So say I've created a new repo and I want to create a GitHub team to house the maintainers for it. So I open up my org and I click New Team. This brings up a new screen where I fill out details and create it. Now GitHub by default puts the person that creates the team in the team. So if I don't want that, I need to go and remove myself by clicking here, and here, and here, and here. Now I'm finally ready to start adding people to this team. I start by clicking here, which brings up this screen where I fill out a name and click invite one by one. Repeat until done or fingers are bleeding. As you can see, any manual process of this kind is going to be time-consuming, requires clicking through multiple screens, many checkboxes, to be able to do something that is very routine. It's also error-prone, and many actions require owner privileges to the org to do very simple actions. Outside of audit logs that are only visible to those people with the owner privilege, there was no visibility into who made what change and when. We needed something that allowed us to, in a simple and clear way, take actions against all of our orgs. We wanted to provide that visibility and audit trail to anyone working in the project, even those outside of our project. Similar to the Kubernetes model, we wanted to reconcile the actual state with our source of truth and make whatever changes we needed to get to that desired state. We needed to be able to delegate privilege in order to expand the pool of people who are able to take on community management responsibilities. And lastly, we needed to accomplish this all in a safe way. We need to ensure the right people have the right privileges and ensure that whatever solution we create doesn't go rogue and potentially lock us out of all of our GitHub organizations.
Great. So the way that we decided to try and solve this problem is by looking at taking inspiration from the way Kubernetes solved this problem, especially the way they use controllers and have reconciliation loops. So the basic way that this works is by having some sort of desired state that you then compare that with the actual state of the world and take any actions that are necessary to drive towards the goal state. So for example, if you're familiar with Kubernetes deployments, you're going to declare something like, I want my pod to have these containers and these number of replicas, these arguments, whatever. You declare that, you then tell the API server that is what you want, and then it will notice if there's any discrepancies. It'll add replicas or remove replicas or delete and recreate a pod with the new image you've declared. And eventually, over time and repeating that, you will eventually get to the state that you want. This works really well for us, and we have elsewhere in the project used this to do things like manage GitHub labels. It's how we declare what branches we want to protect on various repos, and our various automation tools. We use similar things to upgrade from version X to X+1. It's also nice because any errors given with this process, errors are corrected over time, whether you have an intermittent error that's giving you a 500, or maybe you have misconfiguration. The way that you handle that is by either retrying or else fixing the configuration to what you actually want and rerunning. So applying this to our org management, essentially you will declare in some file the set of members that you want and what access levels you would like them to have. Then the tool will read the actual members that you have in the organization and do whatever actions are necessary to go to the state that you want, such as inviting any members that you want that aren't there right now. You can invite them to the org. If they have the wrong level, like if they are a regular member and you want them to become an administrator, you can promote them to admin. And if they're no longer part of the org, you can, it'll then delete them. The same process will apply for the various other types of metadata, or data that's like metadata, the teams, such as what teams exist, who are in the teams, etc. So the name that we have for this is Peribolos, and that is I guess the name comes from a Greek word for a court enclosed by a wall, especially one surrounding a sacred area. This is a picture of the Peribolos outside the Temple of Apollo. And obviously at the Kubernetes community, we really like our community, so figured it was potentially a good name. So the general design is, and our expectations of how we think or expect people to use this is you sort of take your current state of the world and dump that into a file. Then you make any changes that you want to make it more correct across time. Like if new people come, you can add those. We try to make it easy for you to make those changes. Then you run the program, which will do the reconciliation loop. And there's a variety of security mitigations to make sure that it is safe for you to run it without running into that bad situation where you're locked out of your org. We try to make this easy to run and play around with. So right now or whenever, if you want to get started, it's pretty easy to do. You don't actually, if you want, you don't even need to install anything. You can just run the image. We publish images on any commits, so whenever we change it, we auto-publish new images. Obviously, you can also go get it, or you can check out our repo and build it yourself. Again, the first thing we would expect someone to do is dump the current configuration. So we have a convenient way to dump the org, and that will run logs like you see on the right side of the screen, and then it will output the YAML file that it's expecting, which you can kind of see an example of what that might look like on the left. And so then we would expect you're going to use your favorite YAML editor to make any changes. So add any new users who aren't there, or create any teams that are missing, whatever. Make the file how you want it to be, and then the tool is a little bit flexible. Like maybe you want Peribolos to manage the teams that exist, but you don't necessarily want to control like who is in each team. So there are flags to control those things. So you could have the fixed teams, but not the fixed team members, or whatever. There's sort of a bunch of different options, to control that. And so then once you are happy with the configuration you've declared, we would expect you to run the command to apply it. And that's going to do the whole read the configuration you've declared, compare that with GitHub, and make all the changes. So we make it safe by default. So it'll first, by default, if you just run it, it will tell you what it would do without actually making any changes to GitHub. Once you are satisfied with how that actually works, then you can add the confirm flag, and it will make the real changes. We designed this to sort of be easy for people to use. So we wanted it to be re-entrant so that it's important that if something does go wrong, like we said earlier, you can fix it by either using a newer fixed version of Peribolos, or you can fix your declaration to fix the typos that you had and rerun the program. Also, we tried to make design choices that are convenient for people rather than machines, since machines tend to be good at transforming data. So like one good example is GitHub team names are not necessarily unique. So the org can have a bunch of different teams named editor. And those are all going to be backed by a unique ID. But it's not very easy to write a config to declare that, since you don't know what the ID will be ahead of time. So we designed it so that we will essentially require you to have a unique name, and we'll find that ID and then use that. Then if there are extras, we'll delete the extras. Likewise, maybe there are potentially fields that you do want managed and other fields you don't like managed. Like a good one is maybe you don't want to have the private billing email for your org exposed. And so if you just delete that from the config, then we will ignore that. We won't care what the value is. We won't try and drive that towards a particular goal. And then also an important thing, given that we have a large org, is we want to allow delegating parts to different SIGs, which is sort of how we have divided our org into subgroups or subteams. And yeah, so we use that the org member list itself is sort of centrally controlled, and there's more restrictions around making sure that the right things have happened before we invite someone to the org. But once they're in an org, the SIGs themselves, without any other intervention, can declare who is in the teams and what teams for that SIG exist. And you can just merge PRs and have that magically happen. We want, it's important also that we want things to be safe, so we want problems to be more on the funny side of things rather than, tragic. So for example, a more inconvenient thing would be if every time you run it, because of some weird casing issue, we wind up removing you from the org and then 5 minutes later re-adding you. That obviously is less than ideal, but substantially less tragic than if a bug wound up, removing everybody or removing all the admins from the org where you can't recover without, filing a GitHub support ticket. We also have a bunch of, tests and lints to sort of make sure it looks consistent. And some of those tests we will, run at runtime to sort of validate things like there's a minimum number of admins and that the bot has access, and you can sort of even whitelist like particular super users to make sure that even if you've declared removing Christoph, that we won't actually, that the program will reject, that type of config. We've also assumed that if you're trying to do something like delete half of the org, that's probably more likely a typo. You've maybe indented your YAML file incorrectly or something. So we will error out in that type of situation. There are some rate limiting problems with GitHub that we've had to make sure that we're not DOSing ourselves. And then we also want to make sure that we run this in a safe location that isn't potentially running untrusted pre-submit code. So that's sort of how the tool works. And but the more fun thing is rather than just having a file on your desktop somewhere, we want to drive this with GitOps, and Christoph is going to talk about that.
So now we've got this tool, and we want to take this to the next step. So in the Kubernetes community, we have a CI system that we built ourselves called Prow. Prow is modular. It has a bunch of different components, and we use it for every part of our CI, from pre-submits on PRs, post-submits after a PR is merged, and regular cron jobs that will run on a regular basis to check the health of code ahead. So it's split up into all of these modular components, and Peribolos is actually a perfect fit for this system as far as how we've designed it in our organization. So now we've got this flow where you have a configuration that is checked into a Git repo. Prow ends up listening for events and webhooks that are coming from GitHub and is able to process and respond to those. So we use this, again, in lots of different ways. We have chat ops commands to take actions against an issue or a PR. We also listen for push events on PR branches. We listen for merge events on like our master branch, and are able to take action. Prow, in this case, can, with a configuration, spin up a Kubernetes pod because Prow is built on Kubernetes and uses Kubernetes. So we can spin up a job pod with a Kubernetes pod spec and take actions when we hear certain events. In the case of Peribolos, we listen specifically for when a PR merges to your master branch. So when that happens, we kick off a post-submit job on that new commit on master with a pod spec to go run a very specific command, checking out that master at that specific commit and running a tool. So we have a very simple kind of job spec that looks very similar to a Kubernetes pod spec to kick off a job, and this will check out that GitHub, that Git repo, and run Peribolos with the same flags as you saw earlier anytime something merges to that repo. So this is the glue that then takes that. You've got now an authoritative config in a GitHub repo, and when something new merges, you want to take action right away, and you want to change that in your state of the world. So I started off with a workflow of like creating a GitHub team and how many different checkboxes there were. So what does that same workflow look like under Peribolos? So I can now check out this Git repo. I copy and paste a little bit of YAML in the definitions, and I change that YAML to define this new team that I'm creating, and then I open a pull request. Just like we do for any piece of code that lands in Kubernetes, we run a whole bunch of Golang unit tests, we run linters, we make sure the change is safe. That change gets reviewed by other people in the organization, and when all of that is ready, it merges to master branch, a Peribolos run is kicked off immediately, and those changes take immediate effect. So because you express the desired state and let the software do what's needed to get you there, the workflow is more simple and straightforward. We don't need to train folks on the right buttons or checkboxes to use, as the software takes care of all of that. We're also able to drive our own standards and policy with Golang unit tests that catch out of policy changes before they take effect. This, along with the audit trail that is now visible in Git history and delegation of permissions through owners files, allows us to turn around requests quicker and let our developers and community members focus on the project. And what other open source project welcomes you to the org with pony gifts?
So it hasn't always been smooth sailing, and in case you haven't had enough nautical puns this week, but one early issue that we had was around token usage. So that when you run Peribolos each time, it has to pull down the entire state of what exists in GitHub, all your organizations, members, pending members, teams, et cetera. That can take a lot of API tokens, and GitHub has rate limits in place to prevent this abuse, some of which they publicize, other which are sort of secret and internal. And this protects their service from rogue actors harming it. And so when we first turned it on, one visible limit is 5,000 requests per hour, and Peribolos, our org is large enough where we quickly consumed all of that. Obviously that is not good, especially because we were using the single token, so it was shared from the rest of our CI system. So not only did the Peribolos run fail, but then pre-submits that Prow was running elsewhere were failing, which makes people unhappy. So we solved that a couple of ways. One is we implemented a tuning throttling system in our code. That way, you can tell what the limit is per hour and per run, and how quickly you want it to consume those tokens. And so, yeah, so again, following our safe by default, we have it be some reasonable standard, and we can increase it or decrease it as required. And so that way we know that even if you're using the same token through multiple parts of your system, that one part isn't going to consume all of them. And so it'll slow it down, but then that's better than having something be broken. The second thing, which is potentially more interesting, is we have an optional caching layer as part of Prow called GH proxy. that exists in our repo, and that allows us to cache the responses we get from GitHub and revalidate things we get back from GitHub. So we cache the calls that we make, and then we do a no-cost validation. And that way, even if we're consuming 10,000 tokens, obviously most of the time that we run this, most of the teams are the same, so we can just reuse those cache responses, and I'll not have to cost GitHub as much, and so we can run faster and still be just as safe. Let's see. So a second problem is when people change their username. So like, for example, imagine we have a user, Alice Smith, and then eventually she realizes that she can get a much better username that has fewer characters. So she renames herself to that, and GitHub is smart enough to update all the references, updating the name, membership, whatever. Life is great, at least until Peribolos runs. And so since the system's pretty dumb, and we've declared, we still declared that Alice Smith is supposed to be in the org, and we don't know who this weird Alice user is, so we first remove them. Then we see that, hey, Alice Smith is now gone from the repo, so we attempt to add her back to the org, but that user no longer exists, and so Peribolos fails and blows up, and whatever other actions it might take, then it finishes. Luckily, this doesn't happen super often, so our solution, is we expect someone to go in, correct the name to say Alice instead of Alice Smith, and then rerun it, and the next time that will fix itself. But that's obviously something we want to improve. So some other things we want to improve is we'd like to extend Peribolos to manage repos. So there's a similar amount of annoying button clicking you have to do to create new repos. And so we'd like to eliminate that laborious clicking. We also would like to do the same delegation to SIGs, to where SIGs can create all the teams they need. We would like to enable SIGs to create whatever repos they need, and do this with the same pattern that's been working well for us for the org configuration. There's also some interesting edge cases around concurrency, where maybe, like we mentioned, how we'll both kick off we'll kick off the job when you merge a commit, but we also have a time thing. Those could potentially line up, or maybe there's multiple commits that happen really quickly. So you could wind up in a weird state where there's 3 versions of the job that are running slightly different, have slightly different goals. So obviously, eventually that will correct itself, but there could be some weird, case where for a few hours we'll invite you to the org or create a team, and 5 minutes later delete it. That's not good, and we'd like to make that better. We also want to do better delegation. In addition to delegating the repo stuff, we want to, right now we sort of depend on Bazel to stitch together the various files into the one big file that Peribolos actually reads, and we would like to remove this dependency on Bazel and just have it work purely with Go code. So that's, so we'd really like you to, try this, and either by adding some contributions to how we use it in the Kubernetes org, or if it's applicable to where orgs that you interact with, use it there. You can check out, here's the command from earlier to try running it yourself. Here's a link to our source code on GitHub. There's also, you can look at our public declaration. So if you're wondering who is in the Kubernetes org, you can read that repo and figure it out. And if you want to add yourself to a team, you can create a pull request to add yourself to that team. And once merges, you can see all the exciting things happen. And we're a bunch of friendly people. You can contact Christoph and I on Slack or GitHub. Then there's also the SIG Contribex, SIG testing, and prow channels on Slack that we're happy and friendly. So we'd love to talk to you. And here's, if you are not already part of our Slack, you can get an invite from there. Yeah, so that is our talk, and thanks for coming. And if you have any questions, we would be happy to answer them.
Did you guys test the Terraform GitHub provider? And when did you, if you did, when did you start pulling your hair out with it? And why did you choose to write your own?
We looked at that when we were originally trying to find a solution. But at the time, there's a bunch of like extra things with Terraform, like we needed to find a way to store state. We needed to, there's a whole bunch of problems that Terraform would have introduced that weren't conducive to our model. So as Eric was saying earlier, we were looking to the Kubernetes model of, hey, can we design something where we just have this is desired, this is real world, do whatever you need to drive forward to that without needing to maintain that third kind of post of what was the state of the world the last time Terraform ran. So it just wasn't fitting to what we needed to do specifically, as well as the way we write it, like we're writing everything in YAML as far as most of our configurations. So having that be in that same format that a lot of our other configurations are in made it very easy for our users to kind of pick up and use the tool themselves as consumers without needing to know what else is under the hood.
Is github.com hard-coded in, or can you change it to GitHub Enterprise instance?
Right now, I think it is hard-coded in how it's set up, that we're hard-coded against the GitHub API. But we have some, there is some ongoing work in prow in general to make it more flexible and to work with GitHub Enterprise. So that's definitely something that we would be open to, is like a configurable flag to change the host to be able to talk to a GitHub Enterprise instance. All the same APIs that we're using are available on GitHub Enterprise as well.
There are flags to sort of say what the endpoint is, but there seem to sometimes be some edge cases. Like, we don't typically use GitHub Enterprise, but there are users of Prow who use that, and so we've been receiving some pull requests to enable it more of Prow's functionality for that, and yeah, so I'm not sure. By the way, we also have, if anybody wants a Prow sticker, you can come up afterwards and get them.
Any other questions? Great. Thank you so much for coming. We really appreciate it. And please try it out.